Design is an intrinsic human activity which enables people to develop solutions to the problem that they need to solve through synthesis, analysis, and discovery. Curiosity plays a major role in initiating and deriving these creative activities. Curiosity has its roots in human thought, processes that culminate in raising the question why, why not, and what if. In some fields that do not require manufacturing, materials, and long-term testing, to answer these questions, such as the information technology industry, the transition from curiosity to implementation has occurred relatively quickly, as attested by rapid development of the IT industry accelerating the pace of innovation. The design used to be done and is still practiced in many organizations based on experience and trial and error processes, including extensive prototyping, building, and testing. Many companies depend on their expertise and accumulated database to design and manufacture their products. Both experience and know-how are invaluable in these processes, often generating a reservoir of knowledge and trade secrets. People have also designed and created public organizations such as universities and governments, often through trial and error processes. It is simply amazing how much humanity has improved the quality of life and advanced technologies through these trial and error processes of creating new products, solutions, and eventually wealth. Humanity has generated many amazing products and processes through these empirical approaches. The human ability to design and create has culminated through such an achievement as Apollo 11 that took human beings to the moon in 1969. Notwithstanding the amazing human achievements of the past 3 centuries, depending only on experience and adopting the design build test process of creating new products or systems, have their limitations. Such a process is slow and expensive because it requires extensive trial and error procedures, costly experiments, and testing of prototypes. In some cases, these purely experience-based approaches to design have resulted in unanticipated failures of the newly created system that resulted in the loss of human lives and extensive cost overruns. Strictly experience-based design approaches have led to failures due to the mistakes and inappropriate decisions made, especially when the new set of requirements deviates from the old ones. There are many well-known examples of failed designs due to these design build test practices in product and system development. Famous examples are airplanes that fell out of the sky, nuclear power plants that exploded, newly constructed airports that have incurred significant cost overruns and delays, and many costly failures of consumer products such as automobiles due to faulty ignition switches. Design based on fundamental principles of design should augment experience-based know-how, which should assure the creation of successfully designed systems and products that work the first time around without repetitive redesign and incremental changes to overcome design errors. Rationally designed products and systems based on design principles also simplify analysis and testing, reducing the time and cost associated with innovations of new technologies, products, and systems of all kinds, including organizations, software, and hardware. Some people believe that design is an experiential subject, which cannot be taught well at universities. They claim that design could be learned only through experience. This experiential school of design has dominated the design field until fairly recently. As a result, many people engaged in the creation of new design solutions, including engineers, depended on repeated trial and error processes and their experience in creating new systems and products. They use the repetitive cycle of design, build, test, and redesign, build, test in developing new products and systems, including organizations. This experience-based design practice is equivalent to attempting to improve the efficiency of jet engines without knowing the fundamental laws of thermodynamics. Similarly, design cannot be done rationally, minimizing mistakes in the absence of fundamental design principles. Axiomatic design, AD, was advanced about 40 years ago to overcome and eliminate the costly trial and error processes of design. The goal was to enable us to make the right design decisions and avoid making mistakes and wrong solutions in the development of new products and systems. Since the advent of axiomatic design, many innovative products, processes, and organizations have been created quickly and reliably. Many people have become much more creative after learning axiomatic design. These results are not surprising, because the design axioms are distillations of common features found in rational designs. The axioms were discovered through the examination of past design decisions that had generated good designs and often highly creative products. The purpose of this book is to teach axiomatic designs to students in all fields of intellectual endeavor who are interested in the synthesis of innovative systems and products. To learn axiomatic design, students must acquire the language of axiomatic design, that is, definitions of keywords, axioms, mapping, domains, the independence axiom, and the information axiom. They are not difficult concepts to understand, but must be able to follow the logical reasoning used in axiomatic design. The need to design exists in most fields of human endeavor. We encounter design in many different contexts and situations. Sometimes it is driven by human curiosity and by problems that must be solved. Design principles discussed in this book help in both of these situations. Curiosity arises when something violates the design principles. These principles also guide the process of creating solutions to the perceived problem. The design is done to achieve a set of goals. In other words, without a clear set of goals, we cannot commence design. Once we define the goal, we can identify the problem that must be solved to achieve the goal. Based on the identified problem, the designer can establish functional requirements that must be satisfied to solve the problem. Then, the designer must look for design ideas and the corresponding design parameters that can satisfy the functional requirements of the design. It is a creative process that could be lots of fun, because the process of conceiving something new that no one else thought about in the past is challenging and exciting endeavor. There can be many equally acceptable design solutions, but often there is a superior design. The joy that follows when we come up with creative ideas can be intoxicating. Furthermore, the same design thinking that leads to innovative designs applies to many different problems in many diverse fields. This book presents the process and the principles that will lead to the creation of designs after we identify the problem creatively, effectively, and efficiently, regardless of the specific field of application. Axiomatic design leads to rational and useful design solutions in all areas of synthesis. By being able to identify weak or bad designs early, it prevents the creation of a design that is not acceptable, thus improving the efficiency of the design process. In practical terms, it means that a person who is good at dealing with design issues can be useful in many other fields where synthesis is essential. The following are real design stories that illustrate how important it is to establish the goals and identify the problem that must be overcome to achieve the goal, leading to new design solutions.